This is part 2 of your lecture for Monday, February 8th. In this part, I'm going to be going over some important applications of using electromyography. First of all, it allows you to assess which muscles are activated during specific exercises. It allows you to assess the amount that the muscles are activated, and it also allows you to assess muscles that are under strain during work situations. So it's important for injury prevention with that last application. So the first thing I'm going to go over is how it allows you to assess muscles that are activated during specific exercises. And when you use weightlifting machines, down in the gym, you'll notice on the machines they often tell you, which muscles are trained by using that machine. And you can buy, instructional booklets that go over different types of exercises and show you exactly what muscles are being activated. So the way they come up with these diagrams, so the top one here is an example for deadlift exercise. You can see it's a pretty good exercise because it activates a variety of muscle groups in your upper and lower body. The way they determine this is they would place EMG electrodes on different muscle groups and then assess the activity to see which ones are activated the most. And you can see an example of a chin-up, and you can see that you're activating a lot of the muscles, first of all in your elbow flexors and also in your back. So there's just examples of using EMG to determine the specific muscles that are activated during different exercises. And that can give you a better idea of how to train if you want to be targeting specific muscle groups. Another application of the EMG is that it allows you to assess the amount that muscles are activated. So you can compare a type of exercise, or two different types of exercise, and determine which one is best for activating the muscles that you want to train. A good example of this is doing exercises in stable versus unstable environments. So here's an example of doing a squat or doing a push-up exercise, but using this half ellipse type of apparatus that allows you to introduce some instability to your exercises. So a lot of sports will involve stabilization muscles in your trunk, and so it's recommended to include some of this in your resistance training because it has greater applicability to sport. So you can use EMG to assess which type of exercises are best for activating the muscles you want to train. So is it better to train in stable or unstable environments? So here's some multiple choice questions that kind of show you the benefits of training in unstable environments, and also some things that aren't as beneficial for training in unstable environments. So which of the following would involve greater motor unit activation of stabilizer muscles? So you can see the person doing biceps training on a kind of a Swiss ball. So would it be biceps training on a Swiss ball or biceps curls while standing on the firm ground? You can probably guess that it's biceps training on the Swiss ball would involve greater activation of stabilizer muscles. So what I refer to as stabilizer muscles in this case is mainly muscles in your trunk, so in your abdomen area in your back, but also to a degree the muscles in your legs would also be activated here to allow stabilization during this exercise. So again, this might have greater applicability to a lot of sports situations where you're performing your sport in an unstable type of environment. Now, in which situation would you be able to lift a heavier weight? The correct answer here would be the biceps curl while standing on the firm ground. So in this case, training in an unstable environment is at a disadvantage if you want to train to lift a heavier weight. So if you want to increase your maximal force. And this last question, in which situation would you be able to train with a greater velocity of movement? Again, the answer is B, biceps curl while standing on the firm ground. So again, if you want to train for maximal velocity, it's probably better to do it in a stable environment. So training for maximal force or maximal velocity is probably better in a stable environment. Training in an unstable environment will allow you to better activate the stabilizer muscles in your trunk, your back, probably in your legs as well. And that would definitely have greater applicability to a lot of sports situations. So some advantages and disadvantages of training in unstable environments. And this is just a little cartoon that I pulled up on training in unstable environments. So this is an EMG study we did comparing two different types of exercises, both using the squat exercise. So one was using a squat exercise with free weights, and one was the squat exercise using the Smith machine. You can see that the Smith machine is on the left-hand side. The free weights are on the right-hand side. So with the Smith machine, it allows you to do the exercise in a more stable environment. So you can see that the machine holds the barbell kind of in a rack. So a lot of people do this because if they're not confident with doing a free weight squat, the Smith machine squat might be safer for them and easier to perform. But this one is definitely more of an exercise in a stable environment. So the machine is stabilizing the weight for you, and this one is more of an unstable environment where you have to use balance and stabilize the weight while you're lifting it. So we did a study comparing, you can see the EMG electrodes. We got a lot of electrodes there. They're hooked up to a bunch of different muscle groups, and we assessed EMG activity in the trunk and the leg muscle groups during this type of exercise. And here is our results graph. So it's pretty busy, but I'm going to walk you through this. You can see at the bottom, it's Shane Schwarmbeck, who works as a lab technician now for us. This was done when he was an undergrad student, and this was part of his honors research project. You can see it's published in the Journal of Strength and Conditioning Research. What we have here is on the y-axis, you can see the EMG mean absolute value. So that's the amount that the muscles were activated for each of these activities. The black bars in this graph represent free weight muscle activation, and the white bars represent the Smith machine muscle activation. So one thing you'll note here is that the free weight resulted in a substantially greater amount of muscle activation compared to the Smith machine, probably just because you're doing it in an unstable type of environment. And both the trunk and the legs are acting as stabilizers. So, at first we thought that maybe the Smith machine, you'd get a greater activation in your leg muscles, but it turns out that the leg muscles are not only used as prime movers for lifting the weight, but they're also also activated quite a bit as stabilizers. So here you can see for each muscle group, the black bars are greater than the white bars, indicating that the free weight squat resulted in greater activation of your muscles compared to the Smith machine. And you can see I've divided them up into lower leg. The lower leg, you have your free weight TA, which stands for tibialis anterior. You have your Smith machine, and then you have your free weight and Smith machine gastrocnemius. So those are the muscles in the lower leg. The quadriceps, we have your vastus lateralis, that's the VL, and you also have the VM, which stands for your vastus medialis. So two types of muscles in your quadriceps. And then the hamstrings, we have the biceps femoris. That's basically a fancy name for your hamstring muscles. And then in your trunk, we have your rectus abdominis, that's around your stomach area. And then your ES stands for erector spinae, and that's in your lower back. So substantially greater activation of all those muscle groups using the free weight squat versus the Smith machine squat.